Good afternoon, everybody. My name is Frasca, and what I'm gonna show here is just a part of the results that we obtained during my thesis work. And in particular, I will try to convince you that at the very end of the Mediterranean subductive system here, we have during the Miocene several thrusts and massive strike-slip faults that are acting at the same time. And I will try to do that using field argument. So first of all, why we decided to go to the westernmost part of this subducting system? Well, as you can see from the possible scenarios, the debate is open. I mean, it's great because somebody proposed a retreat of the slab toward the west, somebody else toward the south, somebody else rolling back toward the north. So what are we going to do is we are going to check the rocks of the upper plate. You can see colored here in this area in southern Spain. And we will try to understand the kinematics of the upper plate and the timing of the movement in this upper plate. And in particular, we will focus in the very end of the system here, where the chain starts to bend and to swing and to make an arc, and where we can see mantle rocks at the surface. So geological record in the upper plate. In this area, we can see, well, this is the tectonic map of the area that I showed before in the larger scale map. Here in the north, we can see the sediments of the Mesozoic sediments of the Iberian margin, so the subbatics that are at the base of this tectonic log, at the base of the NAPPE stacking. And then we can see here the upper plate metamorphic rocks with two units, so units made of metamorphic rocks and sediments, and then on the top of everything, an entire section of thin lithosphere that is emplaced on top of the Mesozoic Iberian margin. From the tectonic map, what we can see is that the thrusts that we can see here in the tectonic log, they are oriented north 50. In the same area, we can see normal faults that are oriented north 140. And always here, we can see that these thrusts are connected with the strike-slip, with dextral strike-slip corridors that are oriented east-west. So they are delimiting lower strain blocks. So now we're going to focus more in detail in these deformation zones, and so in the area where the strike-slip corridor is connecting with this place, with this thrust termination of the strike-slip corridors. As you can see from the landscape view of Google Earth, we have the verticalization of the layering in the Mesozoic rocks of the Iberian margin, and this verticalization is sealed by flat-lying Tortonian sediments, giving us an important constraint in the timing of the deformation. And we can see that along this corridor, the strike-slip deformation is involving also Miocene sediments. If we check in this detailed map, so the same rocks that we can see here in blue are in blue also in this geological map, we can see that along this corridor, the faults that you can see here with this orientation, they are progressively rotating, becoming parallel to the strike-slip deformation zone, and this is typical for a dextral simple shear along this big deformation zones. How we understood the kinematics of this deformation zone, where, of course, I said before that the field was very important, so we could observe vertical faults, vertical strike-slip faults, and a lot of kinematic indicators that are often related to mechanical instabilities in the surface between rocks that are different viscosity. And then we can see also, well, we can see several examples. We can see also when the pitch is oblique, we can see often this kind of structures that are related to this, always to this strike-slip shearing. Now if we go to check the end of the strike-slip deformation zone, here we can see that we have two thrusts, the same two thrusts that we can see here in the tectonic log. These two thrusts are connected with this deformation zone, and we can see in the area that the faults and the reverse faults, they are indicating a westward emplacement of these tectonic units So an emplacement of these tectonic units toward the west. And we can see very well in the field with a lot of structures, fault propagation faults and flat ramp structures. So this is, but what is really important is to try to put a constraint in the timing of this deformation, so we could see that these static deformation zones and this splay with these thrust splays of the deformation zone were active already in the Aquitanian and Burdigalian, and then everything slowed down during the Teutonian. Yeah, so I'm going to conclude. And so we can say that these upper plate metamorphic rocks, they are emplaced on top of the Iberian margin with a westward movement, and this emplacement is accommodated by lateral ramp, and this lateral ramp are this strike-slip deformation zone, and by frontal ramp, they are the thrust that we described before in the tectonic log. And what we can say as well is that the strength field that justified the structures that we will see in the field is a strength field that is similar to the current one, because now we know that these rocks are moving toward the west, and we know from the seismicity that we have all these reverse, normal, and isostatic faults. So we have 20 million years of consistent tectonic history, and these structures can be justified with the Nubia-Iberia convergence. So the NAPPE stacking in this area can be related to this convergence at this.
Thank you, Gianluca. So it's clearly more simple than some of the model we were discussing before. Well, I think we have to run fastly after, but yeah, you go ahead.
There's well-documented rotation, isn't there? Block rotation.
Yeah, there's also paleomagnetic.
Are your strike-slip faults bounding those blocks? How
Yeah.
does it fit into your model? It presumably works.
Yeah, this clockwise rotation is related to this texture shearing along this. Yeah, it is documented by paleomagnetic data.
Okay, thanks. So